Okay, for number 1, we are going to use a generic rectangle to write an expression for t of x. T of x is defined as f of x times r of x. F of x is right here, and r of x is right here. So we can rewrite this as t of x equals x plus 3 times 2x plus 1. Now we're going to use a generic rectangle to find the product of the two expressions. So we're going to think of x plus 3 as the length and 2x plus 1 is the width of the rectangle. So we'll have here a rectangle. Length is x plus 3 and the width is 2x plus 1. So now we will find the area of these parts, the 4 parts of the rectangle. So we'll have 2x times x is 2x squared. 2x times 3 is 6x. X times 1 is x. And 1 times 3 is 3. So now we can find the area of the rectangle by adding up the terms that we see here in the parts of the rectangle. So we'll have here t of x equals, we are going to start with the highest exponent, which is 2x squared. So we'll bring down 2x squared. X squared will be followed by x, so we will combine all the x's, and we have 6x plus positive 1x. That's going to give us positive 7x. And lastly, we will bring down the constant term 3. So this is t of x. Notice that t of x has highest exponent of, or the variable x in t of x has the highest exponent of 2. So we say that t of x is quadratic. And because t of x has 3 terms, 1, 2, 3 terms, we call this a trinomial. So t of x is a quadratic trinomial. All right, number 2, m of x equals g of x times h of x. So let's rewrite this. M of x is equal to g of x is x minus 2 times x minus 3. So again, we're going to use a generic rectangle. So I can draw my rectangle here. The length is x minus 2. And the width is x minus 3. So now we multiply. X times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is equal to positive x. Notice that to fill up these boxes, we are multiplying the length and the width. But when we want to write the area of the rectangle, which is m of x, we are going to add like terms. All right, so the variable with the highest exponent is x squared. So we will start with that, x squared. X squared will be followed by x, and we have negative 2x and negative 3x. We combine them together. That's going to be negative 5x. And we bring down the constant term, which is positive 6. This is m of x. Now again, m of x, we notice that the highest exponent here is 2. So therefore we called with this has a second degree, and therefore we call this quadratic trinomial because there are 3 terms. When it's quadratic, we also call this second degree. The highest exponent gives the degree of the polynomial. So a quadratic trinomial is second degree. For number 3, we want to find w of x, where w of x is defined as p of x times r of x. So p of x is 2x squared minus 4x plus 5. So let's write down w of x is equal to 2x squared minus 4x plus 5 times r of x, and r of x is right here, which is 2x plus 1. So we want to use a generic rectangle to find w of x. So, okay, let's draw our rectangle. Okay, the length is 2x squared minus 4x plus 5, so we're going to put here 2x squared minus 4x plus 5. And the width is 2x plus 1, so we'll put here 2x plus 1. So now we multiply 2x times 2x squared. 2 times 2 is 4. X times x squared is x cubed. 2x times negative 4x is negative 8x squared. 2x times 5 is positive 10x. 1 times 2x squared is 2x squared. 1 times negative 4x is negative 4x. And 1 times 5 is equal to 5. So now we are ready to write the expression for w of x, which is, if we examine the highest exponent of x, it is 3. So we start with x cubed, and we have 4x cubed. X cubed will be followed by x squared, and our x squared terms are here. Negative 8x squared plus 2x squared is going to give us negative 6x squared. Then x squared will be followed by x, and we have 10x and a negative 4x. So 10x minus 4x is positive 6x. And lastly, we will have the constant term, which is plus 5. This is w of x. The degree of w of x is 3. Okay, this is the degree of w of x. And 4 is called the leading coefficient. And W of x is a cubic, and there are 4 terms. We call it quadrinomial. So this is called a cubic quadrinomial. Okay, another name we can call it is a third-degree quadrinomial. Okay, let's go to number 4. Number 4 is n of x equals f of x times g of x times h of x. Okay, so let's go back to the table and find out what f of x is. Okay, well, maybe I don't have to go to the table. I have f of x right here, which is x plus 3. G of x is x minus 2, and h of x is x minus 3. So let's just write that down. So n of x equals f of x is x plus 3. G of x is x minus 2. And h of x is x minus 3. So to find n of x, we are multiplying 3 binomials. So when we're multiplying 3 numbers, we actually just multiply the first 2 first. Then whatever the result, we multiply by the third number. So we will follow the same thing here. So what we want to do is multiply x plus 3 by x minus 2 first. And then whatever the answer is, we will multiply that to x minus 3. So let's make a rectangle to find the product of the first 2 binomials. So here the length is x plus 3. That's my first binomial. And the second binomial will go to the width, which is x minus 2. Now we multiply, we'll get x squared here, because x times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. Therefore, this is x squared. So the product of the first 2 binomials is x squared. 3x minus 2x is positive x. We bring down a constant term. Now, this result should be multiplied by the last binomial, which is x minus 3. So that means we need another box or rectangle. Okay, we will have 3 partitions for the length because this product is a trinomial. So we're going to put here x squared plus x minus 6. And the width is the last binomial, x minus 3. Okay, and then now we will multiply. X times x squared is x cubed. X times x is x squared. X times negative 6 is negative 6x. Negative 3 times x squared is negative 3x squared. Negative 3 times x is negative 3x. And negative 3 times negative 6 is positive 18. So now the area of this bigger rectangle is equal to n of x. So we're now ready to write the expression n of x, or the function n of x. N of x is equal to, the highest exponent of x here is 3, so we're going to start with the cubic term, which is x cubed. Then the x squared, we have 2x squared, which is x squared minus 3x squared. That's going to give us negative 2x squared. Negative 6x minus 3x is negative 9x. And then we bring down positive 18. So this is our function n of x. Now there are 1, 2, 3, 4 terms. So this is another cubic quadrinomial, or third degree quadrinomial. Okay, the leading coefficient is 1, and this is the degree. Let's go to number 5. So in number 5, we want q of x equals r of x times p of x. R of x times h of x times p of x. So I have r of x right here, which is 2x plus 1. H of x is x minus 3. And p of x is right here. So we can rewrite q of x here. Q of x is equal to r of x is 2x plus 1 times h of x. There's h of x right here, x minus 3 times p of x, and p of x is right here. So 2x squared minus 4x plus 5. All right, so let's just bring this up. So again, we have here 3 polynomials. So we have 2 binomials and 1 trinomial. So the first thing we want to do is to multiply the first 2 binomials, and whatever the result is, we multiply to this trinomial here. So we need to make a box or a rectangle to find the product of the first 2 binomials. So the length for this is 2x plus 1, and the width is x minus 3. So x times 2x is 2x squared. X times 1 is x. Negative 3 times 2x is 6x, and it should be negative. Negative 3 times 1 is negative 3. Therefore, the area of this rectangle is 2x squared minus 5x minus 3. Then we will multiply this to the last polynomial, to the last trinomial. So we're going to make a bigger rectangle here. And we can think of this as the length and this as the width. So we have a trinomial for the length and a trinomial also for the width. So both length and width will have 3 partitions. Okay, so for the length, we can put 2x squared minus 4x plus 5. And then the width, we can put here. Notice that we can interchange the length and the width. So for the width, we'll have 2x squared minus 5x minus 3. So now let's multiply. 2 times 2 is 4. X squared times x squared is x to the 4th. We will add those exponents. So when we're multiplying, we add exponents. 2x squared times negative 4x is negative 8x cubed. 2x squared times 5 is 10x squared. Negative 5 times 2x squared is negative 10x squared. Negative 5 times negative 4 is 20. X times x is x squared. Negative 5x times 5 is negative 25x. Negative 3 times 2x squared is negative 6x squared. Negative 3 times negative 4x is 12x. Negative 3 times 5 is negative 15. So now we are ready to write the expression equivalent to q of x, which is highest exponent is 4. So we'll have 4x to the 4th. It will be followed by the x cubed. Ooh, this should be x cubed because x times x squared is x cubed. So therefore, we are going to combine these two terms here. Since they're both negative, we add them up and we get negative 18x cubed. Now x cubed will be followed by x squared. So we'll have here 10x squared, 20x squared, and negative 6x squared. So if we add all the positives, we'll have 30x squared. Then from that, we subtract the negative x squared. So 30 minus 6 is positive 24x squared. Then x squared will be followed by the x's. Negative 25x plus 12x is negative 13x. And lastly, we'll have a constant term, 15, negative 15. So we notice that q of x has 1, 2, 3, 4, 5 terms. And the highest exponent is 4, or the degree is 4. So we will call this quartic. If the highest exponent is 4, we call it quartic. And let's just call this polynomials. Or polynomial, there's only one. So this is a quartic polynomial. Again, the degree is 4. Leading coefficient happens to be 4 also. This is called a constant term. There's 1, 2, 3, 4, 5 terms. And for that, we just call it polynomial. Okay, lastly, number 6, we are looking for C of x. C of x is v of x times p of x. Okay, we don't have v of x here, so we have to go back to the table. V of x is 2x cubed minus 4x squared minus 13x plus 2. See if I could remember that. 2x cubed minus 4x squared. So let me write this down first. 2x cubed minus 4x squared. Okay. 2x cubed minus 4x squared minus 13x plus 2. This is cubed minus 13x plus 2. Okay, and p of x is right here, 2x squared. This is p of x. So 2x squared minus 4x plus 5. All right, so we are multiplying a 1, 2, 3, 4 quadrinomial by a trinomial 1, 2, 3 terms. So again, quadrinomial times trinomial. Well, there's only two polynomials, so we just need one rectangle. But we're going to need a big rectangle. Okay, so for the length, we can have 4 partitions for our quadrinomial. And for the width, we can have 3 partitions for the trinomial. Okay, so our length is 2x cubed minus 4x squared minus 13x plus 2. And the width is 2x squared minus 4x plus 5. Okay, so now let's find the product. So 2x cubed times 2x squared is going to be 4x. We add exponents, so it's going to be 5. So 4x to the fifth. Next one, 2x squared times negative 4x squared is negative 8x, and 2 plus 2 is 4. Then 2x squared times negative 13x is negative 26x cubed, because 2 plus 1, there's a 1 hiding here, is equal to 3. And then 2x squared times 2 is 4x squared. Negative 4x times 2x cubed is negative 8x cubed. No, to the fourth. Because okay, again, negative 4 times 2 is negative 8. X times x cubed is x to the fourth. Okay, negative 4 times negative 4 is positive 16. X squared times x is x cubed. Negative 4 times negative 13 is 52. X squared. And negative 4x times 2 is negative 8x. Now this is a 5. Okay, that looks like a 6, so let's fix it. This is supposed to be a 5. Plus 5. So now 5 times 2x cubed is 10x cubed. 5 times negative 4 is negative 20x squared. 5 times negative 13 is negative 65x. 5 times 2 is 10. So now we can write the expression for c of x. It's going to be, okay, the highest exponent is 5, so we'll have here 4x to the 5th. And then followed by x to the 4th. And because we have negative 8 and negative 8, that's going to give us negative 16 x to the 4th. Notice that when we are adding like terms, we do not add exponents. When we're multiplying, though, we add exponents. Okay, so here we're just going to be adding the like terms. So for the x cubed, we have positive 10 and positive 16. We can combine the two positives and then subtract the negative from it. So 10x cubed plus 16x cubed is 26x cubed minus 26x cubed. That means the x cubed will disappear. They'll cancel each other. So no more x cubed. Then we is followed by x squared. So add the positives. So 4 plus 52 is 56. And we take away the negative. So 56 minus 20 is positive 36 x squared. Now these two guys, the x's are both negative, so we will add them up. So that's going to give us negative 73x. And then lastly, we'll have the constant term 10. This is c of x. Now the degree of c of x is 5th degree, because the highest exponent is 5. So we will call this quintic. Okay, quintic polynomial. Okay, in this polynomial, the leading coefficient is 4, the degree is 5, constant term is 10. We call this quintic polynomial.